Hello, my name is Thomas Shingling, and I am the project lead for NavBus. Our team consists of Jacob Brooks, Daniel Sullivan, Stephen Arita Murcia, and David Molnar. Project supporter is Naver, and our project mentor is Dr. Nambas Abba. The goal of our project was to create a bus analyzer for a military standard communications bus protocol called Military Standard 1553. This protocol is typically utilized by avionics equipment in aerospace. For our bus analyzer, we needed to be able to passively record ongoing transmissions on the bus and store those transmissions individually in hex on CSV or text files that could be read by Naver employees. Our system was to be robust, utilize military standard hardware, be portable, and mount to existing military standard 1553 connections. The capture transmissions was to be stored on an external storage device. The way our system works is that it directly connects with Navigator's test equipment to listen in on transmissions. The system then couples the signal with transformers and isolation resistors so that a military hardware chip from Holt Integrated Circuits can receive the signal. This received signal then gets processed and transmitted to our microcontroller, which then writes it to a CSV file on an external hard drive. The system utilizes four HI6136 model Holt integrated circuit chips that are built and designed for processing military standard 5053 signals. Each chip has 4 bus channels with a total of 16 different receiving channels from NavAir's test equipment so that each channel can be tested and recorded properly. Each 8 channels are transform coupled while the other 8 channels are direct coupled, utilizing our stepper coupled design shown at the bottom. 8 channels are also set for primary receiving channels while the other 8 channels are for redundancy. Our team also created a word generator for testing our design without utilizing additional expensive equipment. This word generator was built on a Raspberry Pi 400 with a 16-channel relay board to send transmissions to every available bus channel on all 4 chips of our design. Our word generator is capable of sending realistic transmissions provided from Navair themselves from our word generator to our design so that we can prove the utility of our bus analyzer. On the poster, you can see an example rail transmission with a given command word followed by data words. Our final product utilizes a customized PCB board with 2 voltage regulators and an Arduino microcontroller inside an EMI protective housing. Note that the 2 military standard connectors can be utilized by Naver along with 2 feedback LEDs to receive any sort of additional data, a USB interface for the external hard drive, and it comes with a grounded power supply. Overall, testing our design with the given relay board and word generator resulted in successful transmissions. We can see the transmission from our word generator produced the correct waveform on an oscilloscope, be received by our system, and showed the same transmission on a CSV file in an external hard drive. Note the example file pulled from a real transmission shown on the right. Looking ahead, this design could be useful in an additional testing module utilized by Naver that can be improved upon for gathering better results with an easier and more customizable interface. We look forward to seeing our design make strides at Naver testing avionics equipment. We'd also like to make a shout out to Holt Integrated Circuits for partnering with us to provide the military standard equipment for creating our senior design project.